Okay, so we now have our boat. We have several different configurations here. We know where our water line is. Now, this is, again, simple geometry, but if you had something really a lot more complex with maybe some lofts in there or some swept volumes, calculating it by hand would be a nightmare. And this is where SolidWorks would really come in handy, being able to calculate that for you. Also, you take a look at some of the other things it would able to tell you. It tells you the mass, the volume. It also tells you the surface area. Now, how that can help you in this particular design is helps you calculate how much area you're going to have to cover with duct tape. Do a good overlapping, so you're probably going to want to figure out the area that a roll will cover and then double it. The other thing is it also gives you the center of mass right over here, the footprint of a person in here, and extrude it up to the weight of the person and see how that changes the center of gravity. But probably the next most helpful thing that you can get is probably using the stress analysis. And this is not going to give you a definite answer, but it'll actually give you kind of a area of where you might need to strengthen your boat design. So I'm going to show you real quick how to do that. I'm just going to go up here to Tools, and we're just going to use the simple one. We have actually a more advanced tool down here, but we're going to try to keep it simple. We're just going to go to Simulation Express, let that load up, and I'm going to go ahead and select Next. And first of all, it's going to ask you to add a fixture. So I'm going to select Fixture. And it gives you an example of a simple beam right here. How do you actually fix the boat? Because it's not like a simple beam. It's not actually connected to a fixed location. You can't anchor it. Majority of your force is going to be pushing up, your buoyant force. So I'm going to go ahead and select the bottom here. Make sure your arrows are going in the right direction. And so it selects face 1. And I'm going to go ahead and accept that. And we can play around with to see what other options we have. But let's go ahead and play with that. I'm going to go to Next. Now we need to load it. So we need to add a force. So I'm going to select Add Force. We're not going to do a pressure. Now, where is the force going to be applied? Well, again, I think that's going to be a distributed load over the entire area. Although your two people are going to have kind of a more concentrated area in here. And you can go in here and create a surface to apply only to that area and see how it changes your results. But let's just keep it simple for right now. I'm going to go ahead and select the distributed force over this face. And I don't want SI units. I want to go ahead and change that to IPS. And foot-pounds, we figured that was what? 450. So I'm going to type in 450. And per item, so per face. You can add additional ones if you want, but I'm going to give it a distributed surface over just one. And I'm going to go ahead and check that. Done with that, so I'm going to go to Next. Applied balsa to it. If you didn't, then at this point you'd have to apply wood. And balsa is probably about the closest that I've been able to find to react and weigh similar to cardboard. So there's your Young's modulus elasticity and your yield strength. So I'm going to go select Next, and let's just go ahead and run the simulation. And it runs it a whole lot faster than most of us can do calculating by hand. And now this is all exaggerated, but it kind of gives you an idea of where it's going to be moving the most. And it plays this animation. Looks really cool. But it does tell you where it's moving the most. So right here, I'm going to stop the animation. And yes, continue. And you can show the von Mises stresses. Kind of rotate that around. See where all the stress is right there, but also see how it's deforming the side right here. And if you watch a lot of the boats in the videos that's on the SUU website, you'll notice that truly a lot of them actually do kind of cave in on the sides here. Now, I don't know how accurate the actual measurements are, but if anything, it gives you a general idea of your design and where your problems are. So what I'm looking at right here, I would say it's probably going to be a good idea to come back in here and put a stiffener. And it looks like maybe the stiffener might be better off down at the bottom, or maybe put a stiffener one at the top and one at the bottom. So let's just go ahead and do that, and then we'll just run this animation again and see what it changes. Okay, so I've created a sketch inside the boat here. I've constrained it to the center of this part, and I made it 1 inch thick and 6 inches wide, which is kind of a little overkill, but it's almost easier to make it bigger using the cardboard and duct tape than smaller. So now I'm going to go ahead and exit my, I created a section view there, so I'm going to go ahead and exit that sketch. And now we want to go ahead and extrude it. And we want to extrude it to up to next. There we go. Apply it. And then let's go ahead and return to study. And OK. And now you notice it's not bending as much. It is bending down here, so I still might want to yeah, probably. Look how much that's bulging in there. Show displacement. I would actually, yeah, definitely. It helps up here, but I'm going to have to come down here and put another stiffener in there.